So we have this question here saying recall that one parameter distribution of a random variable y belongs to the exponential family if its probability density or probability mass function can be expressed as this equation here, where q, t, a and some known functions and theta is a canonical parameter. So A, state the properties of q. So we know it wants to get that form. So A, we know the properties of q, so this will be from the lecture notes or the series that I've just done. We know that q needs to be a non-negative function, must, a little issue there, must be non-negative, and that it must integrate all sums to 1 for all the values of theta, so like a normal probability mass function here. So integral or sum of f of y for all values of theta to 1 for all sums being a theta. So that's question 1 done. Just use only 2 marks here. Number 10, question B's are 10 markers, so that's question 1 done. We can get rid of that and move on to question 2. So for B it says consider the exponential GLM where the responses are yi, where I is between 1 and n, are independent and exponentially distributed with the mean of mu which is greater than 0, and the densities follow the form of this. Show that exponential distribution belongs to the exponential family of distributions by writing down qy, ty, canonical parameter theta and a theta just for answer. So essentially we want to get this form into this. So the way that we do that here is that we know we have this, so we can write that down or we can not. We need to rewrite it so into this form. One thing we can do is essentially get this e at the front and find a log for this yi, so we get yi given theta equals exp, and we know that if you log an e it gets out, so we can put that log in, but as it's below it has to be a minus of the log because it's 1 over, so minus log of mu, and then we can just take this into the function. It's like a normal mu there. So that's that. Obviously you forget about this part because it's behind the comma, so we can make this look a little bit nicer and try and get it into this form here by doing exp equals theta y minus a of theta. So this is quite similar. This is not meant to be a, whoops, not meant to pencil, so just gonna get rid of that. So now we've got it in a similar form where this is the exponential of this equation. We can then figure out what each links to from this equation. So we know that qy, sorry this keyboard keeps jumping up, we know that our qy, as there's nothing before, must equal 1. That's quite an easy one. We know that our ty here, which is before the theta, must equal just y. We know that r theta, which is in here, it's in both the a and theta, must be our canonical parameter, which is 1 over the y. As you can see here, we've kind of moved that theta here, and we know that RA can then, and RA equals minus log, click the button on my pen, minus log minus theta. So that's question B there for you. We'll move on to question C now. So for C it says use the expression of A to find the mean and the variance of y in terms of mu. So we go C here, we know that the expected value of y So the mean equals the derivative of this a function, and the variance of y equals the second derivative of this function. So we know that a of theta equals minus log minus theta, and we know that this theta is minus 1 over mu. We can differentiate this, so we get a1 equals 1 minus 1 over theta, which then we sub in our minus 1 over mu, so we get minus 1 over mu, which just simplifies to mu. And then ia2 is just our second derivative, which becomes 1 over theta squared, again subbing in our parameter, or something to a minus, my bad, 1 over 1 minus mu squared gives us mu squared. So our mean and our variance, so we have 10 bugged out again, expected value of y equals mu, and the variance of y equals mu squared. Moving on to